Let me share my screen. Sorry about that, Mal. Previous class ran a little bit long, so threw me off a little bit. Okay. So it's no major announcements. Welcome, gentlemen. Hope you all had a great weekend. Hopefully your exam 2 went well. I'm still kind of working on the grades. Whatever set of grades I was working on was just taking way longer than I anticipated. So, those should be updated within the next couple of days or so. Now with the midterm, there's not a midterm exam. It's really your midterm grade. The way I do it is it's just a snapshot of where you are at that moment in time. And so it's going to be based on all assignments through exams 1 and 2, and all of those assignments are based on chapter 1, right? Okay. The midterm grade has no bearing on your final. Again, it's just a snapshot of where you are at that moment in time. If your grades are low, you got to do something different to get a better outcome. If your grades are high, then you're in that category of maintenance, trying to maintain whatever it is you've been doing, right? If you are like trying to boost your score, you're welcome to always go back and redo any of your assignments. If you made below a 90% on an assignment, you should be able to go back, redo it, and improve your score. Again, you're still going to get a limited attempts. The system is only going to show your highest score, right? If you made above a 90, then it's not going to go up past the due date. Okay. As always, if you have questions, feel free to unmute yourself and we can talk about it. Otherwise, I'm just going to kind of get into the material. So today, we are going to be moving into chapter 2 on polynomials and rational functions. And so we'll start today with section 2.1, quadratic functions. A few objectives. 1, graph a quadratic function in standard form. 2, graph any quadratic function. And then 3, solve problems modeled by quadratic functions. So a function of this form, f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, where a is not 0, is called a quadratic function. All right, we've kind of explored this already, where we had our library of parent functions, and we had the one that was a squaring function. It was based on this, right? So now we're going to dive a little bit deeper to the squaring function, specifically the quadratic function, and just kind of explore some techniques for graphing these specific types of functions. I'll check attendance again in just under 10 minutes. I usually do a second wave around the 15-minute mark. I know we're missing, my records show we're missing like two students. I think he was in my waiting room earlier then. I don't think he came back. He left and came back, or he didn't come back, but I think I saw him. I remember that name. But anywho, let's keep going. So a quadratic function, f of x equals a times the quantity x minus h squared plus k, where a is not equal to 0, is in standard form. The graph of f is a parabola with the vertex h comma k. The parabola is symmetric with respect to the line x equals h. It's called the axis of the parabola. If a is positive, the parabola opens upward. If a is negative, the parabola opens downward, right? So similar to like with lines, like when we have a line given to us in slope-intercept form, which is y equals mx plus b, I feel like that's the easiest way to graph a line because you get so much information from the equation. For quadratics, it's a similar thing with the standard form. This gives us information about the coordinates of the vertex. This tells us which way the graph opens, whether it opens up or down. This also automatically gives us the axis of the parabola, or the axis of symmetry. And then once we have the axis of symmetry, whenever we get a point on one side of the axis, we automatically get a point on the other. So that we can use the axis to quickly generate points and then get a better sense of our graph. Okay. So here we're asked to find the standard form of a quadratic function whose graph has this vertex and passes through this point. Okay. So if you have a formula sheet, this is a good formula to update with your formula sheet. The standard form of a quadratic. So that's going to be f of x equals a times x minus h squared plus k. Now they gave us the coordinates of the vertex, so that's our h and our k. And then if it passes through this point, this is going to serve as our x and our y. So let's plug in these different components and see what we're given, how this evolves. So I don't think we were given any information on a, so that's going to persist. And what I'm going to do is replace each unknown with a blank set of parentheses. So then we have x minus h squared plus k equals y. Again, I replace each unknown with a blank set of parentheses. And then I'm going to plug in what we're given. So we said x is -4. So the blank parentheses help us to keep track of our signs. H is -3. Okay. Without the parentheses, it might be difficult to see the double negative there. It might even merge into 1, so let me see. Our k is 4 and our y is 7. Okay. So then if we simplify this, we got a double negative is positive. -4 plus 3 is -1. -1 squared is 1. 1 times a is just going to be a. So all of that first part collapses down to a plus 4 equals 7. So then a equals 3. Okay. So then our function is going to be 3 times x minus h. And now if we say minus a -3, double negative is positive. So instead of writing x minus a -3, we're going to write it as x plus 3 squared, and our k is 4. So I'm going to say plus 4. Okay. Start. This is like my third time going through this material today, and I'm just thinking to myself, I was like, I could use my video because it's the same presentation. It's like, so it's like it kind of, it's a little bit repetitive for me. So just give me a moment. All right, let's keep going. Okay, so I feel good about this. Let's keep going. 3 times x plus 3 squared plus 4. Yeah, that's what we got. Okay. Okay, that's fine. So here we're asked to sketch the graph f of x. Okay. So notice that this is already in standard form. So it gives us a lot of information off the rip. The coordinates of our vertex, which is going to be our h comma k. Our h in this case, remember, is x minus h. So if it's x plus 2, that means our h is going to be -2. And our k in this case is going to be 12. Our a, which is our leading coefficient, is -3. Notice that that's less than 0. So that means our parabola opens downward. And then we have the equation of our axis of the parabola, which is going to be x equals -2. Okay. So if our vertex is -2, 12, that puts us in quadrant 2. And then the parabola opens downward. So it looks like we're focused on like quadrants 2 and 3. So let me introduce some graph paper. So -2, 12. Okay. So let's put our vertex, let's put it about here. Okay. So we'll let our positive x go in this direction. We'll let our positive y go in this direction. X, this is our y. Okay. We got negative 2, 12. Let me see. 2, 4, 6, 8, 10, 12. We had just enough there. Then negative 2. Let's go negative 1, negative 2, negative 3, 4, 5, 6. This is the origin. This is our 1, 2, 2, 3, 4, 5, 6. I think this was 2, 4, 6, 8, 10. 4, 6, 8, 10, 12. These are negative. These are negative. All right. So let's go with vertex negative 2, 12. That puts us about there. Okay. Then we have our axis of symmetry is x equals negative 2. Let's see. Okay, that's decent. Okay, let me label some of these components. So this is x equals negative 2. These are the coordinates negative 2, 12. Okay. So then since we have this axis of symmetry, whenever we get a point on one side, we automatically get a point on the other. So for instance, like when x is 0. When x is 0, the corresponding y, let's see, that's going to be a 2 squared is 4, times 3 is negative 12, plus 12 is going to be 0. So that means it passes through the origin. And then so if we went right 2, we're at 0. So that means when we go left 2, we should also be at 0. So right here. Let's see when x is 1. When x is 1, let me see, 1 plus 2 is 3 squared is 9, times 3 is negative 27. That's an 8 and 7, it's 15. It goes off our chart. So it looks like when x is 1, we go off the chart. Let's do when x is negative 1. When x is negative 1, plus 2 is going to be 1, squared is 1, times negative 3 is negative 3, plus 12 is going to be what? 9. So when x is negative 1, the corresponding y is 9. Right here. Oh, undo. So notice when we go right by 1, we're at 9. So when we go left by 1, we should also be at 9. Okay. And then basically we need to go off the chart before we reach like to the right of negative 5 and to the left of 1, right? So then if we connect all these with a smooth curve, we're going to have something kind of like this. I don't know why it gets all squiggled like that. I'm going to try again. Let's try going this way, see if this is any better. Okay, that'll do. That's fine. All right. Let me just kind of move the stuff around a little bit. Move out there. So paper, I'm going to check my attendance in just a moment. And I'm just going to kind of resize this and reposition it just a little bit. Okay, so when we did it by hand, we got this image. And if we compare it to our prepared notes, I think we get the same image, right? Axis of symmetry, the vertex, the parabolas up and downward. I think we got the same y-intercept, 0 and -4. Okay. All right, let's check Zoom, see how you guys are doing. Students. Yeah, the one, he must be. He's here, okay. Okay, I don't know, that's fine. Okay. Let me mark this, the only person I'm missing. Okay, let's keep going. Okay, so too bad. Okay, so in this example, we're asked to sketch the graph of this quadratic. Now, there's a couple of ways we can go about this. What I'm going to do, I'm going to do a showcase on converting from this general form to the standard form. In order to convert to the standard form, we're going to use a factoring technique called completing the square. And, you know, for our class, we do expect you to have some level of proficiency of factoring. If I say the phrase completing the square, you don't feel comfortable with that, I would encourage you to do a YouTube search and watch a few people, you know, watch a few videos on how to complete the square. That's one of the special factoring techniques. I'll do a demo here, but it's also a good idea to just get multiple perspectives and multiple views or angles. So completing the square, right? So again, we're going to use completing the square to convert this from the general form to the standard form of a quadratic. This is one technique. We'll do this one, we'll do the best we can with it. And then I'll try to highlight another way we can go about this. So if we want this in standard form, all right, let's start by getting a copy of the original. And then we're going to do completing the square. So the original, we got f of x equals 2x squared plus 8x minus 10, okay? So the first step in completing the square is that the leading coefficient needs to be a 1. And we can accomplish this goal by factoring that out of all the terms, right? So this is going to be the same as now. If we factor out a 2 from every term, that's going to leave us with x squared plus 4x minus 5, okay? So then now that we got that leading coefficient to be a 1, essentially, so now comes the completing the square step. Completing the square, basically what we're going to do is add 0 in the form of, we're going to say plus b over 2 squared and minus b over 2 squared. We're going to insert it right here, okay? So we're adding 0 in the form of that plus that, right? Okay, so then if we do this, we'll have x squared plus 4x. Our b in this case is 4. 4 divided by 2 is 2. 2 squared is 4. So really what we're doing is plus 4 minus 4. The minus 5 persists. So now that we've added 0 with a proper number in its proper form, what we want to do is group those first 3 terms together. And then now those first 3 terms can be factored, and they could be factored before, but again, I really wanted to just do a demo on completing the square. So then if we keep going, 2 times the first 3 terms are going to factor into x plus 2 squared. Minus 4 minus 5 is minus 9. And then if we distribute the 2 properly, then we'll finish with 2 times x plus 2 squared minus 18. So notice that when x is 0, y should be negative 10. When x is 0, that's what? 2 squared is 4, times 2 is 8. 8 minus 18 is negative 10, right? So we successfully converted from the general form to the standard form using completing the square. Okay. So then once it's in this form, we can quickly identify the coordinates of a vertex. So then our h comma k, negative 2, negative 18. So our h is negative 2, and our k is negative 18. Okay. So our leading coefficient, which is a, that's going to be 2. Notice that that's positive, so that means our parabola opens upward, and our axis of symmetry, or our axis of the parabola, is going to be x equals negative 2. Okay. All right. So if we're at negative 2, negative 18, that puts us in quadrant 3. The parabola opens upward. Okay. So let's go here. What's the time? Space. Yeah, I totally want to take a nap. Like, I don't know. I know it's like this like every time, but it's just tough, like with you all, like with this group, and I have another group after you guys. And it's just because it's after lunch, it's afternoon. Like I do better with mathematics. I do better when I first wake up. Like after I've eaten and I've gotten, past the peak of the day, I know I'll be struggling. Like when I was a student, I mostly did most of my math homework like in the middle of the night. I would wake up at like 2 or 3 in the morning, and that's when I would do most of my homework. If not there, the other place I would do homework is when I was doing work study at Archer Hall. So between the two of those 2 areas, like I really love like doing work in the middle of the night because everybody like everywhere is asleep. So it's like I kind of have everything to myself. It'd be kind of weird. Like sometimes I go jogging in the middle of the night. It's a little bit creepy, but usually there's nobody out there. It's like a ghost town. I've like, it was so funny. I went jogging in the middle of the night. I think I went with a friend. We started at her house, and we just kind of eventually went our separate ways. But at one point, I found myself like on a country club. I was like, how did I get up on this country club? But I don't know how I got on there, but I was like, okay. But again, everybody was asleep. Nobody was there. So I was like, okay. The weirdest thing I may have experienced is like deer. It's usually nobody out there. But yeah, I really just enjoy like working in the middle of the night because everybody's asleep. So you have fewer distractions. And my mind is clear and sharp and crisp at those hours versus like this hour, I just want to go to sleep and take a nap. It don't matter what I'm doing. Like I just want to go to sleep. I'm always like that. Let's see. Okay, so I think we're working in quadrant 3. Okay, so can I paste? Let me see. Paste. Nice. Okay, style. Let's start off with black. If we want quadrant 3, oh no. Copy. So let's put our cursor. Let's put the origin about here. We'll adjust it if need be. So we'll let this be our positive x in this direction. Then our positive y in this direction. Okay. So again, this is our positive x. This is our positive y. Let me see. The y we need to get down to 18, negative 18. Let me see. 2, 4, 6, 8, 10, 12, 14, 16, 18. Just enough space. Okay. And then on the x-axis, okay, I think we can go by 1, something like this. 1, 2, 1, 2, 3, 5. I think that's good. Here's the origin. This was 1, 2, 1, 2, 3, 4, 5. This went by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. And these guys are all negative. These guys are negative. Okay. And let me go paper. I like to change this to my dots. What's the time? Okay. Already halfway. We're already halfway. Party's almost over. What a bummer. Okay, let's keep going. So, all right, where is it? Our vertex is -2, -2, -18. So that puts us here. Oh, let me paste. And let's do green. Okay. So -2, -18 is here. Okay. So then that's our axis of the parabola. So it's going to go like this. Style 4. And let me kind of, there it is with that one. I guess that's good. Okay. And this was the axis, x equals -2. This coordinate here is -2, -18. Okay. Now let's see. Let's calculate when x was 0, the corresponding y is -10. Right here. So notice when we went 2 to the right, we were at -10. So when we go 2 to the left, we should also be at -10 right here. Okay. Let's see. Let's calculate it when x is 1. So when x is 1, that's a 10 minus 10. Looks like a corresponding y is 0. Okay. So when we went 3 to the right, we were at 0. So that means when we go 3 to the left, we should be at 0. Right here. Okay. Let me add one more tick mark. So then if we connect these with a smooth curve, let me see, maybe that's kind of, I don't think this is any better. Let's see, part of the problem is I can't see those guys. So then we're just going to connect these dots with the smooth curve as smooth as we can get it. That's these. So paper, wait, before I do that. Today, yeah. Shrink you down. It's good about there. Paper. This going. I'm just gonna kind of resize and reposition this. A little bit better. Okay. Looks decent, right? So this is an example on one that we did by hand. We identified our vertex. We could probably label, let me label some of these points. So this was the point 1, 0. This was the point -5, 0. This was 0, -10. So it's -4, -10. We got our axis of the parabola, and we have a vertex. So in this equation, okay. Oh, before we look at theirs, I do want to mention the alternative version of this. So there's this thing called the vertex formula. We could have jumped straight to the vertex. I'll do it in orange, I guess. So the vertex formula, our h, which is the exponent of a vertex, is going to be found by doing -b over 2a, right? So our a in this case is 2, our b is 8, and our c is -10. So then we plug in the b and the a. And then once we find h, which is the x-coordinate of a vertex, to find the k, which is the y-coordinate of our vertex, we're going to say f of h. So whatever answer we get, we're going to pass it through the function. So then once we identify the coordinates of our vertex, then we have our axis of symmetry, and then we can, like, whenever you get a point on one side of the axis, you automatically get a point on the other. It could be just a point. Like, my dog is over there snoring. She snores like a human. It's so funny. And she's this little chihuahua. She has like so much personality. She's like little, but she thinks she owns everything. She thinks she's like the queen of the castle. Then she gets mad, like if I leave her, and I have to lock her in a room or something. She's like, hey, you forgot me. Come, don't leave me. Like, it's so funny. I was like, look, I can't take you with me. Like, I don't know what to tell you. So seamless, and single page. Okay, cool. That's the time. Okay, right. So this is when we did it by hand. So then I think they're using the vertex formula, -b over 2a. So again, the x-coordinate of the vertex is -2. If you pass it to the function, you get -18 like we got. And then they found the x-intercepts and y-intercepts. Now, when I'm finding the intercepts, I prefer to find the y-intercept first, as I find that it's oftentimes easier to find the y-intercept over the x-intercept. With the y-intercept, what do we do? Set x to 0. When x is 0, a lot of the terms cancel. You'll see quickly in this example of the corresponding y is going to be -10. But then when we go to find the x-intercept, that involves setting y equal to 0, and then a lot of times you have to do like factoring, or it can be kind of involved sometimes when you go to find the y-intercept. Sorry, when you go to find the x-intercepts. Okay. But long story short, I think they got the same thing that we got, and you can see it here. Okay. Let's see. Okay, we can take a moment or two to kind of there is one more after this one, but with everybody, this is like the last one that I've been doing all day. So I'm going to kind of stop at the same point with you all. The graph of this function is shown. So first, we're asked to find the domain and range of the function. So in a graphical sense, the domain is going to be the very left to the very right. So looking at this image, we ask ourselves, how far left does this graph go? Keep in mind the arrows mean to continue the pattern. So we ask ourselves, how far left does it go? How far right does it go? So then the domain here is going to be all rails from -infinity to infinity. The range is the very bottom to the very top. So again, if we continue with those arrows in that pattern, it goes all the way down to -infinity. But then the highest that our graph goes is y equals 3. So the range would be -infinity to 3, and the 3 would get a square bracket. Because 3 is included, it actually reaches 3. Okay. And then to solve the inequality, they're asking us, when is this quadratic positive? Or in other words, when is it above the x-axis? So looking at the graph, we can see that it's above the x-axis between our x-intercepts. All right. So they gave us our x-intercepts. So then this quadratic is going to be positive between our x-intercepts, right? So we would say from the left intercept, comma, the right intercept, and those guys will get parentheses because we don't want to be equal to 0. If that were greater than or equal to, then we would use square brackets. But because it's strictly greater than, we use parentheses. Okay. And you see it all here. The domain is -infinity to infinity. The range is -infinity to 3, where the 3 gets a square bracket. And then The region where our graph is above the x-axis is between the x-intercepts, and they get parentheses. Okay. And I'm going to leave this one as an exercise for you all. Okay. If you want to see it, I think it's in my pre-recorded lecture. Are there any burning questions for me before we go our separate ways? Going once, going twice. So again, just to kind of recap, if you joined us late or anything, I'm working on the midterm grades. I have to do a certain couple of groups before others because this is like their final grade. They're like on a quarter system. But that whole thing is kind of taking me a little bit longer than I anticipated, just because I got to go through like all of the paperwork, and I'm just trying to compile everything. But I'll be working on grades over the next couple of days. So your midterm grade should be updated by the next time we meet. If not by then, definitely by the end of the week. And again, your midterm grade is just a snapshot of where you are at this moment in time. It's based on exams 1 and 2, which is basically chapter 1. And if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great day. I will see you Wednesday, same time, same place. Take care, guys. Peace.